Hello everyone. So previously we had successfully designed dynamic feature flag manager, right? So today we are asked to design a configuration manager. Let's see what the question states here. Design an in-memory configuration manager that supports CRUD operations. Yeah, that has to support CRUD operations on key value settings. CRUD operations on key value settings. So this is very important. As we are just going with the in-memory, right? So we'll not be going with any external database, or will not be considering any external database. Uh, Actually, again, design an in-memory configuration manager that supports CRUD operations on key value pair settings, maintain version history as well, and allows rollback to any previous version. Yep. So the system must be thread safe, follow the singleton pattern, and run fully in a single Python file for the demo purposes. So this is the question actually. Yep. So very simple one, right? So based on the question, let's do one thing. Let's quickly collect the functional as well as the non-functional requirements so that we can just move on with the further things, or we can move on with the this one solution part actually. Yeah. Now let's collect the functional and non-functional requirements in detail. So let's move on with the first requirement here. We should be able to store the configuration key value pairs in memory, right? So this is the first requirement. This is fine. The second one is it has to support CRUD operations, get of key, set of key, and delete of key. Yeah, this is fine, I believe. The third one, support versioning. As they have mentioned in the question, it has to support versioning. Every update creates a new version. Every update creates the new version. So this is one of the requirement as well. Very important one. Yeah. The fourth one, this one, it has to support the callback to any previous version. It has to support callback to any previous version. So this is one of the requirement as well. The final one is it has to support exporting the entire configuration snapshot. Yeah, it has to support exporting the entire configuration snapshot. So this is one of the requirement as well. So let's move on with a non-functional requirement here. The first one, in memory fast reader, right? In memory fast reader, right? The second one, thread safe for concurrent reads or writes. Yeah, thread safe for the concurrent reads or writes. The third one, the code should be modular, extensible, and it has to contain, or we have to go with a simple design. So that's what they have asked us to do here. And the fourth requirement here is minimal resource usage. Yeah, these are some of the functional as well as the non-functional requirements. Again, you can just pause the video while discussing the functional as well as the non-functional requirement and look at it. Yeah. Um, Next, based on the functional and non-functional requirement, we will be making the algorithm choice as well as the design pattern choice. Let's discuss the same actually. Yeah, let's move on with the further this one, further things actually. Let's move on with the solution part actually. First, let's move on with the algorithm choice as well as the design pattern choice. Yep. So the first thing here would be this one. What do we call? Design pattern choice actually. Yep. For the design pattern choice, we will be going with a singleton pattern, memento pattern, as well as the command pattern. Singleton pattern, they have asked us to go with the singleton itself. Yeah. So only one configuration manager instance. So we will be going with singleton pattern. That means we'll be going with only one configuration manager instance, the main class or the base class, right? So the second one, memento pattern in the sense each version is a memento snapshot. While write the code, you'll get to know actually this one. Yep. So each version is a memento snapshot. The third one, command pattern in the sense each update is a command producing a new version. Each update is a command producing a new version. So these are some of the design patterns. Yep. So these are some of the design patterns that we need to know. So let's move on with the further things, concurrency as well as the data model. So let's discuss the concurrency part first. So we will be importing the threading module for this first of all, and we will be making use of threading.log. Why we'll be using threading.log here? For the write operations. Yeah, we have to go with the write operations. For that, we will be making use of the threading log. We have to acquire the log, right? For the safety purpose, we'll be making use of the threading.log for the write operations. Yeah, read allowed concurrently as well. We'll be allowing read operation as well concurrently. Yep. And we have to go with a version rollback, and version rollback acquires with the log. Yeah. So this is about the concurrency part. So we'll be making use of the threading module, and we'll be going with these things, whatever we have discussed now. We'll be using the threading.log for the write operations, and also we'll be allowing the read concurrently, and we will be going with a version rollback that this one acquires with the log actually. Yep. So this is fine, I believe. Next, let's move on with the data modeling part. So here we are just going with in memory, as we are not considering external DB, so we don't have to worry about that much, right? So data modeling will be easy when it comes to in memory. Yeah. So we will be going with a configuration store or config store, which consists of the current key value dictionary, as we are going with the in memory, and we will be considering versions as well. Versions comes with a list of dictionary snapshot, nothing but the mementos actually, right? Individual mementos. Version comes with a list of dictionary snapshots, nothing but mementos. Yeah. So each version is a full shallow copy of the configuration. Yeah. Each version is a full shallow copy of configuration. Yeah. So this is fine, I believe. So yeah, shallow copy in the sense, reference copy, right? It's not the deep copy, by the way. Deep copy comes with the different objects, but shallow copy goes with the reference objects, right? The same thing. Will copying the same thing. It's just the reference of what has to be copied actually, right? Each version is the full shallow copy of the config. They have strictly mentioned here, right? So this is fine, I believe. So this is about the data model and the concurrency part. Yep. So this is about the concurrency as well as the data model part. So see, uh, whatever we have discussed earlier, actually, algorithm choice as well as the design pattern choice is completely dependent on the concurrency and the data model part. Yeah. So it is completely dependent on the concurrency as well as the data model part, as discussed. So concurrency and the data model is completely dependent on algorithm choice as well as the design pattern choice. And moreover, one more thing, whatever we have discussed, we will be writing this one in the UML diagram, right? So usually we make use of the high level UML diagram, but for the understanding purpose, and also I'm keeping this one simple. We are going with, or all the 48 problems that we have solved, I have went with a textual representation. Usually people go with this one high level UML diagram, right? I have kept it simple by going with this one textual representation. Yeah, it's better to go with a high level UML diagram. It takes a lot of time. You have to go with the diagram. You have to draw the diagram based on the requirements and based on what we had discussed earlier. So I have kept it simple by going with this one. Textual diagram. So we will be making use of the textual representation itself for all the 50 problems that we'll be solving. Already we have solved 48 problems. We are left with only two. We'll finish it off today actually. But yeah, as I've said, I have made use of the textual representation just for the sake of simplicity. Yep. So now we have discussed the concurrency and the data model part. So it's better to move on with the this one UML diagram part. Yep. So let's move on with the UML diagram part here. So the first thing here would be configuration manager class. Yeah. So configuration manager class, as we are going with a this one singleton pattern. So this acts as base class actually. Base class. This is the only class, and this acts as base class, and it follows the singleton pattern. Yeah. It follows the singleton design pattern. This we have to keep in mind. Yep. So this is fine, I believe. So we will be going with only one class named configuration manager, and which consists of the four parameters actually. Yeah, which consists of four parameters. Yep. So this is fine. Yep. Configuration manager class consists of the four parameters. One is instance, the second one is log, the third one is configuration store or config store, and the fourth one is versions. Right. So this is fine, I believe. Version, log, config store, sorry, instance, log, config store, as well as the versions. And config store uh, is assigned to the dictionary, and will be initializing this one with the dictionary, and versions will be initializing this one with the empty list actually. Yep. These are the four parameters that we'll be making use of, right? So within our code. Yep. So this is fine. And also configuration manager class consists of the five methods. Yeah. So we will be making use of, or we will be going with the five methods inside the configuration manager class. Yep. So this consists of the five methods, namely get of key, set of key value, delete. Get, set, delete we have to go. these things we know because they have asked us to implement the CRUD operations in memory. We have been asked to just make use of the get set as well as the delete. This one we have delete. I mean, this one we have idea on this. This is fine. We have discussed this one already. We will be going with the rollback as well as the export because they have asked in the requirements to do so. Yep. So these are the 5 methods that we'll be making use of. Yep. And rollback and export, they have strictly mentioned in the requirement to go with the rollback, nothing but the previous version, right? So, and also export. Yep. And also export. These 2 methods also will be making use of. So overall 5 methods will be making use of uh, within the configuration manager class, right? So just pause the video and have a look into it. So as I've said, we'll be so I have went with for all the 50 problems that we'll be solving, we'll be going with the textual representation. This is just the textual representation, right? Usually people go with a high level UML diagram. Yeah, don't get confused here. If someone is if you are following someone and you have come here, so I have just shown you the this one textual representation. This is just for the simplicity cause. So we are just understanding the problem and we're just solving. More preference is given to solving the problem rather than this one editing the thing for the YouTube, right? So yeah, so I have just kept it simple. I have just made use of the this one textual or I have just went with the textual representation. Yeah, so this is fine. So within the configuration manager class, nothing but the base class, so we have made use of the singleton design pattern, right? So we went with the 4 parameters again. One is instance, another one is log, config store, as well as the version, right? So this is fine. And then we are going with a get key, set key, comma value, delete of key, rollback of version, and the export, right? And the export. So these are the 5 methods that we will be making use of within the configuration manager class. Yeah, within the configuration manager class. Yep. The same methods we are going to use within the code, right? Whatever the code that we write in the future, the same parameters that we use and the same class we are going to use. So only on class for this one, right? So we are going to use same class methods as well as the parameters. The only thing is we'll be writing the code structurally and we will be adding the logic to the different methods that we have considered within the UML diagram. And UML diagram is completely designed based on what we had discussed earlier, whether it may be algorithm choice as well as the design pattern choice and the data modeling and the concurrency part, whatever we had discussed. Yeah. Um, yep. So UML diagram, we have completely designed successfully based on what we had discussed earlier. And based on the UML diagram, we'll be writing the code. All we are doing again, all we have to do is we have to add the logic to the methods and we have to write the code structurally. These two things we have to do, right? So we have completely discussed the UML diagram as well. It's very good time to write the code. Let's start writing the code. Yeah. Let's start writing the code. The first thing is we have to import the threading primitives for the concurrency as discussed earlier, right? I'll just go with the threading actually. Yep. So this is fine. The next thing is we have to import the copy to perform deep or shallow copies when saving, right? So when saving what actually? When saving the versions actually. Yeah. So let's import the copy to perform deep or shallow copies when saving the versions. And also one more thing. Yeah, first let's import the copy actually. Then we can move on with the further things. Yeah. So this is fine. Then the final thing is let's import any dictionary as well as the list, right? From the typing module, right? Typing for cleaner annotations. So this is optional. Let's go with it. Yeah. So it will be easier if we do this from typing. So I'll just go with from typing actually. Let's import certain things. I'll just go with any. This is fine. And let's this one. Let's go with a dict as well. And I'll just go with a list as well. Yeah. Let's move on with the further things actually. Let's go with a configuration manager class. Yeah. I'll just go with configuration manager. So within the configuration manager class, first thing, so we have to, or we will be going with a single configuration manager as we are going with a singleton pattern, we'll be going with a singleton configuration manager with simple versioning. Simple versioning in the sense we will be going with the individual mementos as discussed earlier, right? So each write, set or delete or rollback, whatever we will be considering, it saves this one. What do we call a snapshot of the current store, right? And also we have to maintain the thread safety. thread safety in the sense it writes guarded by a lock, right? So we'll be making use of the, or we should make use of the lock, right, for the thread safety. Reads are simple dictionary accesses. Yeah, so this is fine. Next, let's move on with a certain thing actually. I'll just go with here. Let me do one thing. Yeah. First, within the this one configuration manager class, first let me go with two things actually. Instances equals none. So this is one of the thing, and I'll just go with the instance lock actually. I'll just go with the instance lock. So let me assign this one to the threading dot lock. Yeah. So this is fine. Yeah. Yep. So this is fine. Next, let's do one thing. Let's move on with the new method actually. So this is completely related to the singleton pattern actually. So basically, we make use of the new method to ensure only one instance is created across the threads, right? And also we have to acquire the class level lock to avoid race during the first time creation. This is completely related to the design pattern actually. If you know what is this one, how do we implement the singleton design pattern in Python? Yeah. So let me do one thing. Let me copy paste only this particular method, right? So just give me a second here. So here I have copy pasted this one, new class. So what it new method actually, what it does again, it ensures only one instance is created across the threads actually. It acquires the class level lock to avoid the race during the first time creation. Yeah, so this is fine, I believe. So first we are going with the if condition. Then what we are doing, we are just initializing the instance attribute. So this part actually configuration store. This is accordingly with what we had discussed in the data modeling in the UML diagram, right? So we are just going with the configuration store versions as well as the store lock. Store lock, we have set this one to the threading.lock. We are just acquiring the lock here. Versions, we have set this one to the empty list as discussed earlier. And config store, we have set this one to the, or we have initialized this one with the dictionary. That's what we have done. Yep. So this is very important. Yeah. So this is fine. Next, what we'll be doing actually. Next, let's move on with the next method, namely get actually. Yeah, within the get method, what we'll be doing, this is going to be very simple. We just have to return the value for key or none if missing, right? So reads are not locked for the performance within the get method. Always remember this, and we are fine for most in memory use here. We just have to return the value for key or none if missing. That is the only thing. One line code. Yep. So just give me a second here. So let's write the get class, get method, sorry. I'll just go with the def here, get. So within the get, along with the self, I need one parameter, nothing but the key, right? Key, which is of type str, nothing but the string. So let me set this one to the key. So I'll just leave a space here so that this looks good. And also here, so which is of the type any, right? So this is fine as per the UML diagram. Yep. All we have to do is we have to return this one, config store. It. So this one has to show actually, not showing. Anyways, let me type this one actually. Config store of so config store. We have to get the value of the key, right? So I'll just go with a get of key, right? So this is fine. Yeah. So I have mentioned the key here, right? Oh, KET I have mentioned. Okay, let me give key here. This error will be gone. Yep. So this is fine. Next, let's move on with the set method actually. Yeah. Set method, set or update configuration key. We are setting or updating the configuration key to the value. And also we will save the new version snapshot of after the mutation, right? So I'll just go with the def. Let me go with set. Along with the self, I'll just go with a key. Let me go with str here, comma value. So I'll just go with any here, right? So this is fine. Let me set this one to the none. Yep. So this is fine. Yeah. So within the set method, so we will set or update the configuration key to the value, right? Or we will save a new version snapshot after the mutation. In the sense, we will acquire store level log to make write plus snapshot atomic. Yeah. So I'll just go with the store log acquire here. Just go with self. Yeah. Yeah. I'll just go with a store log. This one. Yep. I'll just go with a acquire actually. Yep, acquire of, yeah, acquire. This is fine, I believe. So next, let me do one thing. Let me go with a try actually. Within the try, what we will be doing basically, first we have to update the in-memory store, right? I'll just go with config store of key here. So this has to show, at least not showing. Anyways, so let me copy from here, man. Somewhere I gave config store, right? Yeah, let me copy this one actually. Let me paste it over here, config store of key. Let me assign this one to the value. Yep, this one. Next, what we'll do. So why this is showing the error, man? 1 second. Self. Yeah, I'm just going with a store log dot acquire. So this is fine. Try. Why this is showing the error here? Try statement must have at least one except. So yeah, we'll be making use of the except anyways. Will not be going with the except actually. We'll be going with the finally actually. Yeah. So this is fine. Next, let's go with a persist snapshot, right? So we have to go with a different memento, sorry. Yeah. So in this case, I'll just go with save version. Yeah. Save version. Yeah, this is fine. Next, what I'll do, I'll just go with finally actually this keyword. So within the finally keyword, so always release log even or error, right? So I'll just go with here, store log dot, I'll just go with a release. Yep. So this is fine, I believe. Yep. Uh, Next, let's move on with the further things actually. I'll just go with a delete. We have successfully written the get and the set methods, right? So next, let's move on with the delete method. Yeah, I'll just go with delete. Uh, Let me go with the self key of str string. I'll just set this one to the none initially. Yep. So we have to remove key if present and save a new version snapshot accordingly with what we had discussed earlier within the delete method. So let's do the same. First, the same thing actually. Let me copy this one. We have to go with the log or we have to acquire the log, right? So let me give here this one. So within the log, so first again let me go with the try and finally actually here. So within the try, so I'll just write the simple if condition. If key in this one config store actually. Yeah, so let me copy this one. Yeah, let me copy it until here. So let me paste it over here. So let me do one thing. Let me give colon. So within the if condition, we have to remove the key from the store if it is present, right? So I'll just go with delete keyword del. So let me go with config store actually. Let me copy this part. Which part? Config store, this part, right? So let me copy this one and let me paste it over here. And also let me pass the key here, right? So this is fine. The next one, we have to record the change as a new version, right? So I'll just go with this one. What do we call? Save version actually. Yep. So let me go with a save version, right? So this is fine. Next, let me do one thing. Let me go with a finally keyword. Yeah. So this one. So within the finally, all we have to do is we have to go with the release actually. So I'll just go with self dot here. Let me go with store log dot release. Yeah, so this is fine, I believe. So this is it for the delete method. So we have successfully completed the delete method as well. Next, we are left with save version, rollback, these methods, right? Save version, rollback, as well as finally, let's go with one extra method named export, this one. Along with the next three are actually export, this one. What do we call save version, rollback, as well as the export accordingly with the UML diagram. And let's add one more this one method named show versions. We should be able to show all the versions as well. For that also, let's write the method. First, let's move on with the next method named save version, right? So I'll just go with save version actually of self. I'll just set this one to the none. So this is fine within the save version method. So we have to save the snapshot, nothing but the memento of the current configuration. We use copy.deep copy, right? Just to ensure subsequent mutations don't affect the saved versions, right? So let's go with a deep copy that protects nested structures. We are not going with a shallow copy, right? So we need the different object or yeah, we need the different objects actually. We'll be going with a deep copy that protects nested structures. right? So we will change to dot copy if we prefer the, we can change to dot copy if we prefer the shallow copy, right? So for now, we will be going with the deep copy, not the shallow copy here, right? So I'll just go with a snapshot here. Yeah. So let me assign this one to copy dot this one deep copy actually. Yeah, this part. So I'll just go with uh config store actually. Yeah. So let me go with the config config store actually. So let me go with here this one config store. This is fine. And one more thing, I'll just go with this one. What do we call versions actually? Not the save versions actually, just versions. Yeah. So versions, we what we need to append to the versions actually, we have to append the snapshot to the versions, meaning, yeah, we have to append the snapshot to the version list actually, right? So I'll just pass the snapshot here, right? So this is enough. So this is it for this save version method actually, simple one, yeah. Next, let's go with the rollback method. Within the rollback method, we have to roll back to a previous version by index, and also we have to return true if successful, false if the index invalid. After rollback, we save the rollback state as a new version as well. So that's what we do, right? So let's go with the this one. What do we call rollback? Yeah, rollback. Along with the self, I'll just go with the version index. Let me go with the version index. I go with a version index which is of the type int, and yeah, let me go with bool. Yeah. So we will be going with a rollback to the previous we have to roll back to the previous version by index. Yeah, that's what we have to do. And also we have to return true if successful, else we have to return the boolean value false if the index is invalid. Yep. After rollback, we have to save the rollback state as a new version as well. Let's try to do the same thing within the form of code actually. Let's try to articulate the same thing in the form of code. I'll just go with here this one actually. Store mm, lock actually dot acquire this one acquire. So this is fine. Let me do one thing. I'll just go with a try here. So within the try, I'll just go with if zero less than or equal to version index, right? So I'll just go with this version index. Less than length of, I'll just go with version underscore version. Yeah. Yep. So this is fine. Yeah. Yep. So this is fine. We have to replace the current store with a deep copy of the chosen version. That's what we need to do. So let me do one thing. I'll just go with mm, config store actually. Yeah, I'll just go with copy dot let's go with the deep copy again. So I'll just go with the deep copy. Let me go with self dot versions actually. Yeah. Mm, I'll just go with the versions. Let me pass the version index. So this one version index. Yeah. So this is fine. Next, let me go with save version, right? So when it has to show, it will not show a save version actually. When it shouldn't show in that time, it was showing the save version. Anyways, so let me paste this one. Let me type this one over here. So we are just saving the rollback as a new version for the traceability here, right? If everything goes well, we have to return true in that case. Yeah. Else we have to return false. Yep. So I'll just go with else here. Yeah. Else what we have to do? We have to return false in that case. Yeah. I'll just go with return false. Else return false in the sense invalid index, right? So I'll just go with invalid index. The next one, let me do one thing. Let me go with a finally keyword. Yeah. So I'll just go with a finally keyword. So within the finally, let me go with a store lock. Yeah, I'll just go with hmm, let me go with store lock dot release actually. Yeah, this is fine, I believe. Yep, so this is fine. Yes. We are done with the a rollback method. Yeah, let's go with the export method, man. Yeah, I'll just go with the export here. So within the export, I need only cell. Let's consider the dictionary actually, which is of the type string for the key and any for the value. Yep. So this is fine. So within the export method, first thing what we have to do, let's discuss this same thing actually. Yep, we have to return the deep copy of the current configuration state. Nothing but caller can modify the return dict without affecting the manager within the export method. All we have to do is see in the simple terms, we have to return the deep copy. So I have to go with a copy.deep copy, right? So I'll just go with deep copy. I have to pass the config store here, right? So based on what we discussed actually. Yep. So this is it. For the export method. Next, let's do one thing. Let's move on with the show version method. I'll just go with the show version self actually. Let me do one thing. I'll just go with the none actually. This is fine. One second. Let me give the colon as well. So we have to print all the saved versions for the demonstrations of the debugging. Yeah. So each version is shown with its index. So rollback can reference an index. Let's do that by making use of the for loop. So I'll just go with for I comma v here. Each version we are considering, right? And enumerate. So let's make use of the enumerate here. Let me pass the versions, right? So I'll just go with versions. Yep. So not yeah. Anyways, just version. So I'll just go with. We'll be making use of the string interpolation. So let me start with f. So I'll just go with version. So I'll just pass I here. So this is also fine. Then let me pass v over here, right? So this one, simple. Yeah, very simple one. We are done with the show version method as well. Yeah. So let's do one thing. We are, yeah, we are done with the coding part actually. This is it. We have discussed this one step by step. Yeah. So next, let's do one thing. So usually I take the demo version or demo usage or the example usage from the Google. Let me do that. Just give me a second here. So let me come here. Let me paste it over here. So this is the demo version, right? So this is fine. Not the demo version again. So we are going with the configuration manager. We are maintaining the different versions, but every time I'm making use of the versions method. Sorry, versions. This one keyword, not the versions. Demo usage actually. Demo usage or the example usage. Yeah. So this is fine. Let me do one thing. I'll just go with Control J. Let me give clear screen here. So this is fine. I'll just give Python followed by filename.py, right? So I'll just click on this. Let me copy this one entirely. Filename.py. Let me hit the enter. So we are getting some error. Type object configuration manager has no attribute instances. So which line is this? Line number 15. Mm, so we are going with the instances none. Okay. So instances I have set this one to none. So let me change this one to the instance actually. Now this has to work. If we have some other errors, let's see actually. So let me run this one again. Still we have the error. Configuration manager observed no store lock. Did you mean store lock? Okay. Where is store lock actually? Line number 26. Store lock. Mm, dot store lock actually. I have to go with. Mm, line number 26, right? So within the set method actually. So let me change this one to the this one. What do we call store log. Let me add the underscore here, right? So I'll just give the clear screen again. So let me enter configure an object no config store. So this one also. Let me do one thing. Let me add the underscore here. Same goes with the version as well. I believe. I don't know. Yep. It has no save version. Did you mean save version? So where is this save version? Line number 29. 29 self.save version, where we are initializing the save version. One second, one second. So let me search for save version here. Sorry, Control F here. So let me. We have went with the correct one itself. Bro. Yeah, let me change this method to actually underscore save version. So now the error has to be gone actually. Let me again the heck man self versions append. Did you mean versions? Let me go with here. One second. This is fine. Mm, did you mean versions? Mhm. So I'll just go with a. We have to go with the underscore versions, I think. So let me go with. One second. So let's do one thing. Let's change this one to the underscore versions, right? So I'll just go with here. So let me go with this one. Uh, I'll just go with a clear screen. So yeah, let me. If your configuration manager has no attribute versions, where we are doing this line number 72. Again, I have to change everything here, man. One second. Let me copy this one. Yeah, I'll just come to the line number 72. I did change actually. Anyways, so now so many typos. Okay, now we are getting the correct output. So many typos, man. Anyways, so see, accordingly with what code that we have written. So let's discuss this one step by step. First thing, what we are doing, we are calling the configuration manager class here, right? So which is the base class which follows the singleton design pattern, right? So this is fine. Yep. So next, what we are doing, based on what we have written actually, next what we are doing, uh, one second. Yeah, we are calling the configuration manager. So this is fine. Next, we are setting the initial configurations, meaning each call records a new version here. See, uh, we have set this one theme, dark, timeout 30, timeout 30 for the version 1 and volume 80 for the version 2, right? So these two things we have to keep in mind. Version 0 um, saved inside underscore versions, right? Just now we have debugged the same thing actually, right? So there was a mistake actually. I didn't include the underscore actually. Yep. So this is fine. Version 0 saved inside versions underscore versions and timeout 30 is for the version 1 and for the version 2 we have set the volume to 80, right? So this is fine. Next, first for the version 0 we are getting theme dark based on whatever we are doing. So let's discuss this thing and then we can move into the this one with the output part. So for the version 0, this one, three print statements whatever I have included here. See what we are doing, we are displaying the versions that are recorded so far. Yep, we are displaying the this one that are recorded so far. We have to roll back to the version 1, that state after setting timeout, right? So this one, we are setting first this one. We are displaying version 0, version 1, and version 2, right? So version 0, version 1, version 2, and also the version 3. Version 3, we are setting the theme to light actually. In the version 0, we have set the theme to dark. First, see, we are displaying the version 0, 1, 2. See here, version 0 theme dark. Version 1, same thing, theme dark, timeout 30. And version 2, all we had changed here is this one. We have set the volume to 80, right? Version 2, theme dark, timeout 30, and version 80. We are getting the correct output. For the version 3, what we are doing, we are setting the theme to light from the dark actually. We are setting the, see here, this theme we have set we have set the theme to dark in the version 0. We are changing the theme from dark to light in the version 3 actually, and then we are calling then we are calling the same versions actually. In this case we are getting the version 3 theme light, right? So we have updated from theme dark to theme light in the version 3. Timeout remains same, timeout 30, and volume also remains same, volume 80, right? So then we are rolling back to the version 1. We have just rolled back to the version 1 in the sense where we had set the theme to dark actually. Manage this one mgr dot rollback of 1. So we are just printing after rollback mgr.export, right? After this one, we are just rolling back to this one version 0 means here we have set the theme to the light. If we roll back to the same version, if the same version as 0, this one version 0, same to the version 0, then we have to again we are setting the theme back to the dark from light. Instead of the light, we are setting the theme uh, dark to the light. That's the only change. And uh, timeout will be set to 30, right? So this one will be removed. What volume will be removed, timeout will be set to 30, right? The same thing is happening here after rollback. So we are going with the export method. We are calling the export method here. See, after rollback theme, as we are rolling back to the version 0, theme has been set to the dark and timeout 30, right? So we are getting the desired output. So whatever the code that we have written works absolutely correct here, right? Whatever the code that we have written works absolutely correct here. So mm, we have discussed the coding part, we have discussed the output part as well, and we have discussed the this one. We have discussed or we have got the desired output as well. These three things we have done. It's good time to move on with the further things actually. Let's discuss the limitations for the code that we have written. So here, let's move on with the limitations of the current code. The first limitation here would be a full snapshot stored every time, right? So this will increase the memory quite obviously. It leads to the memory growth actually, as we are storing the full snapshot every time, right? So this is one of the limitations. The second one, no persistence. We are not going with any external database here, right? So whenever the program starts or whenever we restart the code, actually, it gets a reset. Yep, resets when program stops. Actually, this is also one of the limitations. So third one, no partial difference versioning. Actually, different versioning. Sorry, entire this one. What do we call? Dict copied here, right? Entire dictionary will be copied, right? Or we are copying the entire dict here, right? No partial different versioning. So this is one of the limitation as well. The fourth one, no advanced concurrency. No advanced concurrency in the sense simple. We are just going with a simple look only, right? So these are some of the limitations that I wanted to discuss, right? So these are some of the limitations that I wanted to discuss. So this is fine, I believe. Next, let's move on with the further things actually. The next one, alternative algorithms and the trade-offs. Alternative algorithms and the trade-offs in the sense, what are the alternative algorithms that we can make use of rather than the algorithms that we made use of within our code, right? So based on the extensibility, will be writing the code actually. The code should be the code whatever we have written should be extendable at any cost, right? So keeping in mind, keeping in mind about the extensibility itself, we always write the code. Just remember this. Yep, the first alternative algorithm here would be different based versioning or difference based versioning, right? So what is diff based versioning here? What does it do actually? Right, see, just listen to this carefully. Diff based versioning, the main benefit of using it is lower memory usage actually, right? So the main benefit only is the lower memory usage. The main trade off it would come with is the complex rollback. The rollback mechanism will be extremely complex. Yeah, this one we have to keep in mind. Second algorithm or the approach, we can just go with the event sourcing log as well. Event sourcing log, the main this one benefit of this is high auditability. Yep, high auditability, but the trade-off would be slower replay. Yeah, so this is one of the important alternative approach or the algorithm. Yeah, we can just move on with, or we can just go with persistent immutable data structures as well. Yeah, so the main benefit or the advantage here would be efficient snapshots. Yeah, it allows efficient snapshots where the trade-off that it comes with is higher implementation cost. Yeah, this is one of the things. The fourth one, so add JSON file persistence. So the benefit or the advantage that it comes with is durable storage. Yep, durable storage. And the main trade-off it would come with is not purely in memory. Yeah, not purely in memory. The main one, the fifth one here, multi-reader multi-writer locks. Yeah, multi-reader multi-writer locks. So the main benefit that it would come with is high concurrency. And the main trade-off that we have to take care of, more complex thread model. Yeah, more complex thread model. Yep. uh, this is one of the con or the trade-off that it comes with, right? It will be more complex thread model. Yep. So we are done with discussing the alternative algorithms and the trade-offs as well. So we have successfully designed configuration manager system, or we have successfully designed configuration manager, right? So I hope whatever we have discussed is completely clear, and along with the coding part and the UML part. Next, we will be designing a tic-tac-toe game. So next, whatever we'll be designing tic-tac-toe game, that problem will be the last problem in the playlist. We will finish this playlist with a tic tac with this one by designing the tic tac toe game, right? So these are the last two problems actually. Yep. So we will finish it off today actually. Yep. So we'll finish it off today. This particular playlist actually we will be successfully solved, or yeah. We have already solved 49 problems. We are left with only one problem. We'll be solving that as well, and we'll finish it off with the with designing the by designing the tic-tac-toe game, right? So that's what. So now we are done with this particular all this one. What do we call? Yeah, we are done with designing the configuration manager system, right? So again, I hope whatever we have discussed is completely clear, along with the coding part and the this one, along with the coding part and what UML diagram part. Yep. So for now, this is it. Thanks for watching, guys.